So let's look at mathematical functions evaluation in MATLAB. Let's assume you have to evaluate a function. Uh, Let me just write down, let's say f of x equals 2x plus 3x cube um, and divided by 5x square. So if you're writing a function, and let's assume that we have two variables instead of a single variable. Let's say fxy. So let me just modify this. 2xy plus 3x cube over 5y square. So now it's a function of two variables. When you put values of x and y, any value of x and y, then the function will be evaluated and the results will be generated. And let's say you want to program this thing in MATLAB so that when you give a value of x and y, your result will be generated. So I'm going to show you right now in the command window, but again, you are not going to be submitting anything from the command window. You're going to be writing in the MATLAB editor. But I'm going to show you in command window, and then I'm going to go to the editor and show you, and then show you that how you're going to be submitting. So in the command window right here, when you are evaluating mathematical functions in MATLAB, the first thing that you do is to assign the values of the variables in the equation or function. So we have two variables, x and y. And you can assign any variable, any value. So let's say I want to assign x equals 2.3 and y equals 5.6, two values. Now you can also assign multiple variables in the same row, just separate them by semicolon. So let's say if I do x is equal to 4.5, that will be a new value that will be assigned to x. So it's gonna 2.3 will be erased and 4.5 will be assigned. And I put a semicolon, and then y is equal to 7.6, another new value. It's not 5.6 anymore. So it is going to be assigned. Now observe, what did semicolon do? It did not show x, it only showed y. So anytime you do not want to show the values or anything on the command window, either it's running from your program or you're writing in the command window, make sure you put a semicolon after that. When you put a semicolon after that, then that value, that variable value, is not going to appear on the command window. It will be there in the memory, but it is not going to appear in the command window. So anyways, so I have assigned x 4.5 and y 7.6, and then I'm going to write the function. Now when you're writing the function, look, mathematically this is the function, this is the equation that I'm defining. This is how you define it mathematically. F is a function of two variables, x and y, and then this is the function. In MATLAB, remember, when you are writing an equation and you're assigning the result to a variable, remember the variable name has conditions that I discussed earlier in the first video. And remember, the conditions are that it has to start with a letter, it can contain only numbers, it can contain numbers, and the only special character is underscore. So you cannot write fxy. You cannot write this and assume this is a variable. Now you can write it, but not to assign a variable. The variable, if the variable is f and it's a matrix, again we're going to learn matrices maybe in 2 weeks. If f is a matrix, then x and y will be the index of that matrix, and it's going to take you to that specific value that's sitting at that index. So f will still be the variable, but you're not going to define a variable in this way. So make sure follow the rules of defining variables. I can write down my variable fxy. I can write down my variable f underscore xy, or I can just write down f. It doesn't really matter. Uppercase, lowercase, doesn't really matter. So I'm just gonna write down fxy. So when I'm writing this equation, 2 times xy, 2 times x times y. plus 3x squared. 3 times x squared. Now this is numerator. It has to be x cubed, sorry, not squared. This has to be divided by the denominator times 5 times y squared. This is how you're going to write the equation. And once you execute it, it's going to take the values of x and y that are in the memory, 4.5 and 7.6. It's going to execute the equation, generate the result of 1.1834. Okay, so you can see the result and everything, but make sure do not, once again, do not submit anything from here. Do not copy and paste and then put it in a Word file or anything and then give it to me. Or actually do not, or you can copy, for example, if you are going to write, and you have to write the program in the editor. So if this is your editor, and let me show you some other rules of writing your program, a good program. So a good programmer, you start your program with comments. In MATLAB, comments are given by the % sign. And it will be green if you're using MATLAB editor. You don't have to use MATLAB editor. If you don't want to, you can just use Notepad. And then, but you have to write in the MATLAB syntax and save it as an M file. But the most convenient way to write a MATLAB program is to use MATLAB editor. It's going to be in color. It's going to show you if something is wrong. It's going to pretty much point that out for you in the MATLAB editor. That, for example, if the parentheses are not matched, then it's going to point that out in the MATLAB editor. You just have to look at it, but it will show you that. So start your program with comments. And what should be the comments? The simple comments can be, of course, your name. Let's say this, if this would be exercise 1. And then I would just go ahead and put date, 03/07/2019. And that will be, I mean, for a simple program, that will be the comment. As simple as that. Now, if you have to define what does this program do and everything, then of course you can write down the comment. For example, this program will evaluate the equation f x comma y equals whatever the equation is, 2xy 2xy plus 3x cubed 3x cubed divided by 5y squared. So you can write some description as what does this program do as comment. That's perfectly fine. Actually, it's a good habit of good programmers. And then since I have already written it here, I'm just going to copy and paste it. So let me go ahead and then copy this. Make sure do not copy these two greater sign. These are the prompt, command prompt. So you cannot do that in the editor. So I'm just going to copy this, x is this, y is this. I'm going to put a semicolon after that as well. And then I'm going to copy this. And that's it. That's your program. So when you're going to run your program, it is going to assign value of x and y, assign value of 4.5 to 4.5 and 7.6 to x and y, and then it's going to execute my file. Observe this is yellow and red, and if you move your mouse on that, it's going to give you a hint. Terminate a statement with semicolon to suppress output within a script. See, it gives you a good hint that if you don't want to show the output in the command window, then put a semicolon over here. It's not incorrect. It's going to run, but then it's going to generate the output. And actually, you don't want to put semicolon right now, because when you're submitting the program to me, and this is the output that I will be checking. So I will be executing your program and checking your result. And if your result is correct, that means your program is written correctly. If it is not correct, then I'm going to go and look at your program intently and see where did you make mistake. But in this case, you don't really want to put a semicolon. If you do, I'm not going to take points off. It's just going to be inconvenient, because then I will have to type the variable name, or I will go to your program and remove semicolon so that I can see your result. Yeah, or I will type the variable name in the command window, and then it will show me the result of that variable. Remember, semicolon just suppress the output. That does not show the output. That doesn't mean it's not going to calculate the output. It is still going to calculate the output, assign it to fxy. So it will be in MATLAB memory. but it's just going to be inconvenient for me to type the variable name or go ahead and remove this. So do not put semicolon. If that's your final result, you want to show me that result, then don't put semicolon. Okay, so this is your program. Save it. Now, it's possible you may be able to find older version of MATLAB for cheap, or your friend may have it. He gives it to you, and that's perfectly fine if you install it and save your M files, because MATLAB files are compatible. They do not depend on which version you're using. So as long as they are M files, they're going to run in any MATLAB, any version. So do not worry about it, as it was the case with the LabVIEW, that it was only backward compatible. It was not forward compatible. That's not the issue with MATLAB. If you get the MATLAB version from 1990s or 2019, it's going to run files. 1990 files are going to run in 2019. 2019 files are going to run in 1990. Again, if you're using some specific function that were not written in 1990, then of course those functions are not going to run. But these simple calculations, they're going to run anyways. All right, save your file. Here, this is how you're going to save. So I'm just going to save on desktop right now. It's going to save. You're going to save it like, oops, first name underscore last name underscore exercise 1. So you save the file, and then when you want to execute the file, then make sure the folder where you saved the file should be the same as where the MATLAB is pointing to. So this is the folder of the command window of MATLAB. So you can do two things. One thing is very easy, one thing is a little harder. Either change the folder to this and then write your file name over here and press execute, and it's gonna run the file. The other thing, which is the easiest thing, which everyone does, I do that, you will do that, which is possible recently. It didn't used to be in 1990s and stuff. But there's a run button right here. So press the run button. It's going to ask you, what does it ask you? To run this file, you can either change the MATLAB current folder or add this folder to MATLAB path. So you can just do change folder right here. That's it. As soon as you change folder, then look, the folder in the command window, it is the same folder as where you saved your program. So it's very important that both command window and or the command window should point towards the folder where you save your program if you want to run the program. In any case, it's going to ask you, and you can just do change folder when you run it. So it is executed. It shows you this is the exercise that is executed, and this is the value of fxy that is calculated. Now if I put a semicolon after that, and when you run it, it will automatically save it. Right now it's not saved. So either you can hit save or you can run it, it will save it automatically. And observe that it did run my program, but it did not show the value. Why? Because I put a semicolon after here. And observe that I have semicolons here and here, so it is not showing the values of x and y either. So if I want to show all the values, let me remove this. Let me put a comma here instead of semicolon. Remove this. Observe now it is showing me all the values because there is no semicolon anywhere. So I don't need to see all the values. I just need to see the final result. So you don't really have to show these values. If you are showing it, it doesn't really matter to me. It's not going to affect your result. So this is how you're going to write a program and save a file as M file, and this file is gonna be the one that you will be uploading on Canvas, one of the files. So there are four programs. Each program will have its own file. So this is how you're gonna do function evaluation. Now, functions can have trigonometric functions. You can have exponential functions, not just x and y. So let's say you are writing a function f of x comma y comma z, a function of 3 variables, and the function is 2x cosine of yz sine of x plus y plus z, and let's say Let's say this is the function. Okay, so cosine and sine. Now I'm introducing trigonometric functions, and I hope everyone has some knowledge about trigonometric function. I hope many of you have taken trigonometry, and and if you're coming from AA degree, of course you have, because you need to have Calc 2. And if you're coming from AS degree, you have used sine and cosine functions, exponential functions in some of the classes, although you may not have taken trig at this time, but you may have used it. So, and again, I'm not examining you on the mathematics. I'm just you're just programming this thing. So in MATLAB, there are many pre-written functions that I can go to the tutorial. And if you look, mathematics and trigonometric function, table 2, it shows you many of the commonly used functions that you can use in equations. For example, if you want to calculate the absolute value of anything, then absolute of x can be any variable or any function. And if you want to calculate the square root of anything, then the square root of that. You can also do x to the power 0.5 or x to the power half, which will also calculate the square root. But there's a function for that as well. If you want to round the value off, then round. If you want to floor the value, that is rounded off to the previous integer, then use floor. If you round it off to the next integer, then you use ceil. So all these functions are available in MATLAB. Exponent, log to the base 10. So remember, if you just use log, it's going to be the natural log, and log to the base 10 is log 10. And then these are trigonometric functions, which are very commonly used: sine x, cosine x, so on and so forth. Observe that there is sine x and there is sine dx. Sine x, when the value of x is in radians, angle is in radians, and sine dx when the angle is in degrees. So make sure if your angle is in degrees, either you can change here, if you can use sine x, but change x from radian to degrees by multiplying that by 180 divided by pi, or just use sine dx. So all these are here in this table, and you will be using some of these functions for some of the exercises. So for example, if I want to program this thing, let me go back, and let's say this is my exercise 2, the second exercise. I'm going to open a new exercise. Let me copy this. Actually, let me open a new exercise. Control V. Let's say this is my exercise 2. The programming will evaluate the equation fxy, comma z. Two x cosine of yz sine of x plus y plus z. And let me add a claw over here. Let's say I would say that assume x is in degrees and y and z are in radians. Okay, so I just added this small thing here. Let me save this program. So I'm going to save it as Masood underscore Ijaz underscore exercise 2. All right, so how I'm going to write this thing. So let's write this first. Let's say I want x, which is in degrees. I want it to be 55 degrees. So x is equal to 55. Let's say y is 2.3 radians and z is 6.7 radians. Now, in engineering, if it is not specified, or if you don't see the degree sign, you always assume the argument of any trigonometric function to be in radians. So this is very important. Remember that. If you don't see the degree sign, or if it is not being told to you, that assume that this angle or this variable is in degrees, then always assume that all the variables, if they are if you're evaluating the cosine sine of those or tan, all the variables, the phase is in radians. So that's pretty much engineering standard. In this case, I'm saying that x is in degrees. So okay, so I assign x in degrees. Of course, you're not gonna assign degree sign, but just value 55. So I'm gonna write this equation. So f is equal to 2 times, now x is in degrees. The result of this is gonna be radian. The result of this is just gonna be numbers, and result of this is just gonna be numbers. And we are assuming that fxyz is just a number. It's not a degrees or anything. So what I'm going to do here, I'm gonna go ahead and change this x into number or radians. So I'm gonna do x times pi divided by 180. So it's gonna change it into radians, which are simple numbers, not degrees. And then times cosine, y and z both are in radians, y times z, and then times sine of, now x is in degrees. You cannot add degrees and radians together. So what I'm gonna do, x times pi by 180. I'm gonna change that into radians. Also, why I'm changing it into radians? Because I'm using sine. I'm not using sine d or anything. So I'm gonna change it into radians so I can add them in y and z, which are in radians already, plus y plus z. Now you don't really need to put parentheses here, x times pi by 180, because again, remember, mathematical operation, priority is that multiplication and division, whichever is coming first from the left side, it's going to be operated. So first x will be multiplied by pi, then divided by 180, and then added into y, then added into z. Here, of course, you have to do that, because if you don't do that, it's going to do 2 times x times pi. Actually, you know what? Even here, you don't have to do that, because it's going to do 2 times x times pi divided by 180, and then it's going to multiply this. So in either way, if you put parentheses here or not, it's not going to make any difference. It's just more convenient for you to see, if you put the parentheses here, that what exactly you're doing. You're converting this x into from degrees to radians. So anyways, this is the program, as simple as that. You save it, you run it, and go to the command window, and this is your result right here, 0.9359. So this is how you are going to evaluate variables, write your program, submit your program. Exercise to ask you to do that. And then, oh, another thing is help function. What is help function? Help function basically shows you help of different built-in functions. So let's say if I do help of sine, then it's going to show you what is function sine and how do you use function sine. Sine x is the sine of element of x. And not only that, it's going to show you some of the closely related functions, and this comes very handy. For example, if I do help of plot is a function that you will use to plot different graphs. Then it's a long help. Observe, it shows you a good help. It shows you what different options you can use with plot. Again, we're going to discuss that in the future. And then when you go at the end, it will show you a bunch of different plotting functions that are present in MATLAB. And maybe some of these functions may be helpful for you in your situation. So many times these functions, they come very handy if you're looking for some specific thing to do with some specific function. So use help as much as you want. It is okay to use in exam, the help command, and it comes very handy. So I use help if I don't know any function. The first thing I do is I do the help of that function and check what does that function do and how to use that function. All right, so next lecture we are going to do vectors.